Good afternoon. It's me, Mr. Werger. Sorry I'm not in class today. I had a doctor's appointment this afternoon, but I'm here on video. I hope you all got your binders out from the back of the room. So we'll try to run this like a normal day as if I was here. So first turn to your beginning of the semester ACT, and we'll talk about problems 11 and 12. 11, that's a good example of what we did last semester in geometry. You have a triangle. The sum of the measures of angles A and B is 47. What is the measure of angle C? So hopefully remember, for any triangle, what do the three angles in any triangle add up to? Add up to 180. And two of those angles, the sum, there's a vocabulary word from the beginning of this unit. So when you add those two angles together, you get 47. So if you just subtract 47 from 180, that's going to give you the measure of that third angle. So 10 minus 7 is 3. We borrowed 1 there. 17 minus 4, 13. So the answer to that one was D, 133 degrees. So just over half of us got that right the first time. That is not too difficult, so I hope if something like that comes up again on ACT, hopefully you can get that one right. You may not have seen a problem like number 12 before. I'll show you how to do it. Once you see how to do it, it's not that hard. So you have a choice of 3 sandwiches, 3 soups, 4 salads, and 2 drinks. So just to kind of show you what's going on here, I'm going to simplify this a little bit. So let's temporarily set aside the soup and the salad. So let's say you're just getting a sandwich and a drink. Okay? And you have 3 choices of sandwiches. So let's say your choices are peanut butter, ham and cheese, and turkey. Okay? And then once you pick a sandwich, then you have 2 choices for drinks. So let's say your choices are either milk or juice. So if you pick the peanut butter sandwich, you can either get milk with it or juice with it. If you pick the ham and cheese, you can either get milk with it or juice with it. If you pick the turkey, you can either get milk with it or juice with it. Okay, so basically I have written out here all the possible combinations. So you can get peanut butter and milk, peanut butter and juice, ham and cheese and milk, ham and cheese and juice, turkey and milk, turkey and juice. So there are 6 possible meal combinations there. Okay, and the shortcut, because if I drew this type of diagram with soups and salads, it would get to be a very big diagram. But we had 3 choices for the sandwiches, and you have 2 choices for the drinks. So if you just multiply the number of choices you have, so 3 times 2, you have 6 possible meal combinations there. So for this problem, you've got soup and salad options as well. So basically you just multiply the number of choices you have for each. So you're multiply 3 times 3 times 4 times 2. 3 times 3 is 9. 4 times 2 is 8. 9 times 8. So if we drew out a diagram like this, there would be 72 possible choices. That's called the multiplication counting principle. Take the number of choices you have for each type of food or whatever the problem is, multiply the number of choices you have together. Okay, so that's our ACT problems of the day. Let's go over a couple of problems from your classwork from yesterday. And I put those in your binder, so that should have been right at the front of the binder when you opened your binder. Was the work we turned in from last time. Let's get a blank page in here. So let's briefly talk about number 8. Number 8 was the absolute value of x equals -11. So remember we had this conversation that when you take the absolute value of a number, the answer is going to be positive. Like the absolute value of 2 is 2. The absolute value of -2 is 2. So if you're looking for a number that when you take the absolute value you get -11, that can't happen. So number 8, the answer was no solution. No solution. Absolute value cannot be equal to a negative number. Okay. Let's talk about number 9. Absolute value of 3x minus 2 equals 6. So most of these problems have 2 solutions. Some of you were able to come up with one of the solutions, but it looked like you didn't even really try to find the second solution. There are 2 solutions. So one solution, if you just do 3x minus 2 equals 6, so if this quantity inside the absolute value, if that's equal to 6, then when you take its absolute value, it will be 6. Okay, and both 9 and 10 answers involve some fractions, so it wasn't necessarily the type of problem you could figure out in your head. So you gotta use your algebra skills here. Adding 2 to both sides, dividing by 3, and then just leave your answer as a fraction. I'm really not interested in decimal answers. So just 8/3. That's less work than typing 8 divided by 3 into your calculator. Hope you can see that. So one of the answers is 8/3. Okay, but there is a second solution. So if the quantity inside the absolute value, if that was equal to -6, and then you took the absolute value of -6, the answer would be 6, right? So we also want to figure out what value of x makes this -6. Same steps, add 2 to both sides, divide by 3, and again we can leave our answer as a fraction, -4/3. So you put -4/3 in for x, multiply it by 3, that's going to give you -4. -4 minus 2 is -6. And the absolute value of -6 is 6. So problems like number 9, number 10, those have 2 solutions. Just like number 7 had 2 solutions. Most of you got 2 solutions for number 7. So those absolute value, where you're solving for x, two solutions. Unless it's something like number 8, if you have absolute value equal to a negative number, then there's no solution. Let's talk about number 13. 13. So there's a fraction in there, negative 4/5 x minus 7 equals 10. Okay, so any addition or subtraction, do that first. Add 7, negative 4/5 x equals 17. Now when you have a fraction, to make that equal to 1, we multiply by the reciprocal, which would be negative 5/4. If the fraction is negative, the reciprocal will also be negative. So when we multiply these together, we want it to equal positive 1. So if this is negative, I need to multiply by another negative to make it positive. So that's going to become positive 20 over 20, which is 1. So now we just have 1x. Then over here, we also need to multiply by negative 5 over 4. Multiplying fractions, we multiply across. 17 times negative 5. 17 times negative 5 is negative 85. Negative 85. And 1 times 4 is 4. So we can just leave it as negative 85/4. If you have any other questions, feel free to hit pause, and maybe my substitute would be able to work through any other problems you'd like to see. Or maybe there's a classmate that got that problem right that you're wondering about, so that would come up to the board and do that for you. So if you want to do that, go ahead. Otherwise, we will move on to today's lesson. So hopefully you've got this handout. We're going to be dealing with some word problems today. And putting the numbers we need into whatever equation we have to answer the question. So many of the problems, and we saw this equation last week, distance equals rate times time. That's an essential physics formula. And many of our examples today will be based on this equation. So distance, so we're talking like either miles or feet or meters. So those are all distances. When we're talking about a rate, so maybe we're talking about miles per hour would be an example of a rate, or feet per minute would be a rate, meters per second. Okay, those are all examples of rates. And then time, so hours, minutes, you could have days. These aren't all the examples, but those are obviously examples of time. Okay, so when you see something in the word problem, just to kind of help you get the numbers in the right place, it helps to look at the units. Okay, so example 1 here, a high-speed train travels between Boston and Washington, D.C. a distance of 457 miles. Okay, so I'm using the equation distance equals rate times time. So the distance is 457. The trip takes 6.5 hours. So hours would be time. Okay, what is the average speed? So speed is like a rate. Like how fast are you driving? Miles per hour, that's like how fast you're going, that's your speed. So that would be an example of a rate. Okay, so we have R times 6.5 equals 457. So to solve that, this is multiplication. So we would divide by 6.5. 457 divided by 6.5. 457 divided by 6.5. Okay, so we might get some decimal answers for these, that's okay. So I would say about 70.3 miles per hour. So the rate equals 70.3. And then you've maybe seen the abbreviation for miles per hour, MPH. So you do want to include units on these, because 70 miles per hour is not the same as 70 feet per second. So the units do make a difference in the answer. Okay? If you have any questions, feel free to pause and have a little group discussion. Otherwise, why don't you take a minute and try example 2 on your own. We can hit pause using that same equation, distance equals rate times time. I'll check back with you in a minute. Okay, so a jet flies an average speed of 540 miles per hour. So that's your rate. How long will it take to fly from New York to Tokyo? A distance of 6,760 miles. So here you know the distance and you know the rate. How long does it take? So you're looking for the time. Distance equals rate times time. So our distance is 6,760. Our rate is 540. We're looking for T. So like the math part of these is not too tough. It's just getting the equation set up properly. Again, this is multiplication, so divide by 540. $67.60 divided by 540. $67.60 divided by 540. So about 12 and a half. Okay, that's 12 and a half what? This is time. Are we talking days, hours, minutes, seconds? Okay, so the answer is right here in the rate. It's miles per hour. So your answer is 12.5 hours. Has anyone ever been on a plane ride that long? I know I haven't. 4 hours is about the longest I've been on a plane. That was long enough for me. Okay. All right, so that's distance equals rate times time. These last couple will be a little different. A person jumps from a plane 2,000 feet high wearing a parachute. The table below shows the person's height at various times. Find the height of the person after 7 minutes. Okay, so at time equals 0, so that's right before they jumped, they were at 2,000 feet. So then after 1 minute, they're down to 1,700 feet. So the height is going down as they're drifting towards the ground. And the question is, after 7 minutes, how high are they still in the air? So before we talk about this, why don't you take a minute or two and see what you can do with that. The question is, how high will they be after 7 minutes? Okay, let's see what you came up with. Maybe you looked at these numbers and saw a pattern. So the height is going down by how much every minute? It's going down by 250 every minute, right? 2,000 minus 250 is 1,750. Subtract another 250, you're down to 1,500. So then I could keep going. So subtract 250, that put me at 750. Subtract another 250, puts me at 500. Subtract another 250. So after 7 minutes, they're going to be down to 250 feet. So maybe you did it that way. Could we use some algebra to figure that out instead of just kind of keep going with the pattern? And the answer is yes, we can use algebra. So we're writing an equation for the height. So the height is starting at 2,000. And then it's decreasing, so I'm going to do subtraction. We're subtracting 250 every minute. Okay, and we're using t to represent time. So if I put in 1 for t, 250 times 1 is 250. 2,000 minus 250 is 1,750. If I put in 2 for t, so 250 times 2 is 500. 2,000 minus 500 is 1,500. So to figure out after 7 minutes, using this equation, it would be 2,000 minus 250 times 7. Type that into your calculator. 2,000 minus 250 times 7. And you get 250. Okay, so, because 7 wasn't much past 4, it wasn't too tough just to subtract 250 3 more times. But if there was a situation that, took longer to hit the ground, so what if it took like 500 minutes for an astronaut to drop from space down to the ground? And you wanted to figure out, okay, after 60 minutes, how far are they? So it'd be a lot more work to, count by subtract 250 like 60 times. So something like that, having a formula would be more helpful. Okay, so this formula has like your starting height, and then this is the rate. So if it was going up by a certain amount, then we'd have addition here that's going down by a certain amount. So this is going down by 250 every minute. So that's your rate, and then times time. So very similar to what we did previously, the only difference is that you have like a starting amount here. Okay? All right, last example. You are hanging 4 championship banners on a wall in the school gym. The banners are 8 feet wide. The wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners, and between each pair of banners. How far apart should the banners be placed? So I would highly recommend drawing a picture. And so let's say that's our wall. And the wall is 62 feet long. And we're hanging 4 banners. 1, 2, 3, 4. Just slide this over a little bit. Okay, so each of these banners is 8 feet wide. So the question is, how far apart should these banners be so that we have the same distance between the banners and the same distance between the banner and the wall? So I'm kind of looking for this distance right here, and it's the same. So I'm going to call that unknown distance, I'm going to call that x. Okay, so there's 5 unknown spaces x plus the banners, and when you add all that up, it should equal 62. So again, this is algebra class, so I would encourage you to write an equation and then solve for x. So how many x's are there here? There's 5 x's. And then if we add up the length of the banners, so 8 plus 8 plus 8 plus 8, which is the same as 8 times 4, is 32. So adding up 32 plus 5x, that should all total the total length of the wall, which is 62. And solving that equation, we should all be good at that by now. Minus 32, that's 30, divided by 5. So the amount of space between each banner should be, put units in my answer, so 6 feet. So if you draw a picture, use some algebra, then that's not too tough, right? If you just read it and you're trying to kind of do it in your head, that could take a while. Okay? All right, so myself will pass out the classwork that is due at the end of the period. So please use the class time to get that done, and then when that is done and turned in, then if you would like to check your cell phones or whatever, that's okay after the classwork is turned in, but not before. We have a test on Friday covering everything from Unit 1. So the other thing you can do with the extra time is kind of page through your previous notes, previous assignments, and kind of review some of those problems. You do have the option of using a note card on quizzes and tests. My substitute can hand out a note card if you'd like to start putting one of those together, if you think that's something you want to use. And we will spend some time reviewing in class on Friday before the test, maybe 20-25 minutes. But it won't hurt to do a little review before that, if you have the time in class. Okay? Have a good rest of your day, and I will see you on Friday.